We were working on characteristic number 2, which was the horizontal asymptotes or the oblique asymptotes. And we start with factoring. So we factor things first. And the top factors to x minus 1 and x plus 7 over x plus 2. So our non-permissible value, x can't equal negative 2, and we have to decide if this is going to be a whole or a vertical asymptote. So once it's factored, that factor of x plus 2 does not simplify and go away with any factors on the top. So that means we're going to have a vertical asymptote at x equals 2. Next, we have group 1. The degree is bigger here. And if the degree is bigger on the top and nothing simplifies, this is the situation where we have an oblique asymptote. And to figure out where that oblique asymptote is, we use synthetic division. So with synthetic division, I put my coefficients here. I'm dividing by x plus 2, so there'd be a minus 2 out in front. I bring down the 1, multiply, add, multiply, and add. And I can ignore the remainder and just look at what is left. Just look at the quotient. So x plus 4 is going to be our oblique asymptote. And we can I start graphing as soon as I have my asymptotes. So here's my graph. I know that I'm going to have a vertical asymptote at x equals 2. Put that in and label it. And an oblique asymptote at x plus 4, well, that would have a y-intercept of 4, a slope of 1, yes.
Why the asymptote is not x equal minus.
Oh, I did that again. Didn't I do that yesterday? Just forget a minus then? Thank you. Yes, it's x can equal minus 2. This will be a minus 2. Sorry. There we go. Can you do that on your paper? Just slide it over? No. I'm sorry. So we have our asymptotes. 1 at x plus 4 and 1 at x equals minus 2. Now, the last part, finding all of our intercepts and seeing if we need any other nice points and draw our graph towards our asymptote. So always, your y-intercept is your easiest to find. Just plug in 0 for x. And I would go back to my original equation here, because if I plug in 0 for x, then I'm going to just have negative 7 over 2. And I can label that point. Zero comma negative 7 over 2. Second, x-intercepts. And the x-intercepts are really easy to see from the numerator of your factored equation. Because if I plug in 0 for y, the only way a fraction can ever equal 0 is if your numerator is equal to 0. And since it's already factored, I can very quickly label 1 comma 0 and negative 7 comma 0. So I can label those points on there. 1 comma 0. So the question after you've labeled your intercepts is, do I have enough points to draw the graph? And to figure that out, you need to have at least 1 point in each section. So the question is, how many sections does this graph have? Well, the sections are separated by your vertical asymptote at x equals 2. The oblique asymptote never makes a new section. So we just have values less than x equals negative 2 and values bigger than x equals negative 2. Do we have a point in the section 1? Yes. Negative 7 comma 0. This is enough to go towards that asymptote and that asymptote. This is what that graph is going to look like in that section. Do we have points in section 2? Yes. So you just have to draw your graph towards those asymptotes. And the graph is done. So steps 4 and 5, intercepts and nice points. You're going to find all of your intercepts every single time. But you need to have at least 1 point in each section. And what that means in our instructions is every time we have a non-permissible value, that breaks your domain up into different sections. So our only non-permissible value was x equals negative 2. And so we had values left of x equals negative 2 and values right of x equals negative 2. If you have points in each of those sections, then you can draw your graph. Okay, let's look at part B. There we go. And it's the exact same equation, just flipped, so I can factor it right away. And once again, now our non-permissible values, x can't equal 1 and x can't equal negative 7. And since they don't disappear, they will both be vertical asymptotes. But since we flip things around, now the degree is larger in your denominator, and that is an easy one. That's group 3. And whenever the degree is larger in your denominator, you will always have a horizontal asymptote at y equals 0. So for horizontal and oblique asymptotes, you're really looking at the degrees of your top and the degree of your bottom. If the degree is bigger on the top, you have the possibility of an oblique asymptote. But it doesn't have to be, because it might simplify and be a hole instead. If the degree is the same on the top and the bottom, you will always have a horizontal asymptote at the coefficients of those highest degrees. And here, group 3, if the degree is larger in your denominator, you will always have a horizontal asymptote at y equals 0. So once I found all my asymptotes, I'll start my graph. So, vertical asymptote, x equals negative 7. Vertical asymptote, x equals 1. Horizontal asymptote at y equals 0. x-intercepts and y-intercepts. So I will start with my y-intercept. If I plug in 0, I would look back at my original equation there and plug in 0, and I will get 2 over negative 7. So I can plug that point in. X-intercepts. If you plugged in 0 for y, take a look at your numerator. Could your numerator ever equal 0? Yes, at negative 2. And this feels wrong. I know it feels wrong, because that point is on that asymptote. It is okay for graphs to go through horizontal asymptotes. Horizontal asymptotes only tell us n behavior. Vertical asymptotes are about non-permissible values. You can never, ever go through a vertical asymptote, because that is a non-permissible value. But horizontal asymptotes aren't non-permissible values for y. They are telling you what's happening at the end of our graph. So we have one x-intercept at negative 2 comma 0. Do we need other nice points? Yes. This is going to be one where we're going to need actually quite a few nice points. Do you see that your vertical asymptote separated your graph into 3 sections? And you have nothing in section 1. So pick any x value in section 1. And I like to go close to my asymptote to start. So I'm going to try negative 8. If I plug negative 8, and I'm going to just do my work up here in orange. Do you see on the top, if you plugged in negative 8, you would get negative 6. And I actually like the factored one because it makes my mental math pretty easy. Negative 8 minus 1, negative 9, negative 8 plus 7, negative 1. So that's going to simplify to negative 6 over 9, which if I reduce it, negative 2 over 3. So I can draw a point right here, negative 8, negative 2 over 3. And technically, once I have that point, that is enough to draw my graph in that section. Now, interestingly, section 2, I'm like, oh good, I have points. But even though I have points, I don't know how to graph it. And I'll show you why. Because, like, obviously on the right here, these two are going to have to connect. And then it has to go down towards the asymptote, because if you went up towards the asymptote, you would make a new x-intercept. And you already found all the x-intercepts. So this is sort of a caution. If you draw your graph, and in drawing your graph, you make a new x-intercept after finding all the x-intercepts, that's going to obviously be a mistake. So if I didn't know which direction to go here, I have to go down towards the asymptote instead of up towards the asymptote. Because if I went up, I'd make a new x-intercept. And I already found all the x-intercepts. But to the left of negative 2, I am a little bit unsure. Because negative 2 is right on here. Is it possible it could go down towards the asymptote? Or up towards the asymptote? The answer is yes. Graphs could do either one. It doesn't create a new x-intercept. So since I don't know, and I'm unsure, anytime you're unsure, just find another nice point. So since I'm unsure what's happening between negative 2 and negative 7, I might pick negative 6. Let's see what happens when I plug in negative 6. So again, I'm going to erase the orange work that I had done before. Take out my orange pen again. And if I plugged in -6, the top would be -4. -6 minus 1 is -7. And -6 plus 7 is +1. So I get the point -6 comma +4/7. And this tells me, oh, it had to go up towards that asymptote instead of down. Something you can also sort of use to cheat from previous units. If it would have went down, do you see that that would have been like a bounce? If it would have been a bounce, like if I wanted it to go down, I could add a little 2 there and square that. That would give that x-intercept a multiplicity of 2, then it would bounce. This time though, it has a multiplicity of 1, it makes sense that it will go straight through. It's not bending there, even though the whole graph is bending. It's not bending and flattening out, it's still going straight through at that point. And still we have no points in section 3, so I would pick an x value of 2, something just to the right. And I'll take out my orange pen again. And if I plugged in 2, the top would be 4. 2 minus 1 is 1. 2 plus 7 is 9. And I get 2 comma 4/9. So sometimes you don't need any other points. This one, we needed 3 additional points to finalize our graph. But the rules stay the same every single time. So graphing rational functions, you're going to need your asymptotes. So I sometimes, when I'm trying to remember the steps that I need to do, I'm like, okay, after I factor, I need my asymptotes. Non-permissible values will give me vertical asymptotes, but then I also have to look for horizontal asymptotes and oblique asymptotes. That's sort of steps 2 and 3. You can kind of remember them together just by saying, I need to find all of my asymptotes. Then I draw my graph, I draw those asymptotes. Okay, now I need to put some points on here. I for sure need all my x-intercepts and y-intercepts. And sometimes that's enough to draw my graph towards the asymptotes. Other times I need additional points, so I just pick random x values. I usually pick them really close to my asymptotes. Sometimes that's good. Sometimes you get a point that's so far off your graph, you're like, okay, I'm going to pick another one. And then you draw your graph towards your asymptote. Okay, you can circle the questions 6 and 7.